Let's take a quick look at all the transformation for the vertex form of the function. If a is positive, we learn the function opens up and it has a minimum value, which means that in terms for the range, all the y values are greater than k. If a is less than 0, the function opens down, which means the function has a maximum value and all the y's are less than k. If a is a value greater than 1, then the function is vertically stretched, narrower, or if a is a proper fraction, the function is vertically compressed or wider. If the value of h is positive, we have a right shift. If the value of h is negative, we have a left shift. If k is positive, the function shifts up, and if k is negative, the function shifts down. And I did give you examples for h being positive or negative. Now let's get to work.
The past two videos we've graphed different functions, and now it's time to put all of these together. In this first function we have a situation where a is less than 0, which means, based on what we learned, that the parabola will open down. When a is a negative value, the parabola will open down. So that means that my function will have a maximum point or a maximum value. And we're going to try and see what that maximum value is based on where the graph is situated. Now looking at the function, we have x plus 2. And we learned that when we have a plus inside the bracket, the h value is negative, which means the vertex is negative 2 and 0. And the axis of symmetry will be x equals negative 2. Based on this information, we can deduce that since the function is now moving along the y-axis, the maximum value will be 0. Now with quadratic functions, we saw that the domain can be really any real number, from negative infinity to positive infinity. Let's graph this function and let's see what it looks like to determine the range of the function. So we shifted our parabola 2 units to the left, we reflected it over the x-axis, and we see that now every y value will be less than 0. That's the maximum value that the parabola can attain. So we can write that y is an element of the interval negative infinity including to 0. So 0 is included in that range interval. For the second function, we have y equals 2 times x minus 3 squared. So in this case, the a value is a number greater than 1. And we did notice a couple of days ago that when a is a value greater than 1, we have a vertical stretch of 2 in this case, which means that every y value is amplified. Again, h is 3 and k is 0, so the vertex is 3 and 0. And the equation of the axis of symmetry is x equals 3 because it corresponds to the x-coordinate of the vertex. Now, since a is positive, my parabola opens still up, which means I have a minimum value. And in this case, the minimum value is 0. Because I am shifting 3 units to the right, but it's still along the x-axis, so I haven't moved up or down away from the 0 point. Now, since I have a stretch of 2, for every increase in x value, I increase 2 units along the y-axis, so I've graphed my stretch properly. And thinking of the range, now every y value in this function will be above the minimum point, which is 0. X again belongs to negative infinity to infinity, while y will always be greater than 0, or we say it's an element of the range 0 to positive infinity. Let's look at the next function. Now we have negative x squared plus 3. So since the a value is negative, we have a reflected function, so it will be reflected over the x-axis. And in the same time, the h is now present, which means it's 0, so it doesn't move anyway horizontally, but it is translated 3 units up. So the vertex will be 0 and 3. And the axis of symmetry stays at x equals 0, like the basic function x squared. Now let's think about the maximum or minimum of that function. Since it's reflected, it will have a maximum. And because my function is moving 3 units up, it means the maximum value that my function can get equals 3. So y equals 3. Well, the reason I like writing the maximum or minimum first is because we can easily read the range of the function of the graph. Since the y values will never be above 3, it means they'll always be less than 3, which means they go from 3 anywhere to negative infinity. And with ranges and interval notation, we write it from smallest value to greatest value. Now we have a combination of translations and reflection. So we have a reflected function, which means I have a maximum value. Also, we notice that we're going 3 units to the left and 4 units up. So the h value is negative because we have x plus 3. So I have to translate my function 3 units to the left.
Now let's look at the other transformations. First I'm gonna reflect the function, and it's reflected 3 units to the left, 4 units up. Now reading the vertex from the graph, the vertex point is negative 3 and 4, which means that the axis of symmetry, or the equation of the axis of symmetry, is x equals negative 3. With quadratic function, the domain is x values are elements of the real numbers domain, while with the range, the graph really tells the story based on the maximum or minimum value. Since the maximum of this function is 4, which means the value attains a maximum value of 4, y will always be less than 4, which means it's an element of the interval negative infinity to 4. And we use the square bracket for 4 to show that we're including that value. Next function is 2 times x minus 3 squared. So we have an a value of 2, which means the function is vertically stretched, and an h value of 3, which means the parabola shifts 3 units to the right. So let's draw the function. We have to stretch the function, so for every increase in x, we go 2 units up along the y-axis, and in green we have the new function. Now, reading the vertex of the graph, the vertex is 3 because it moves 3 units up to the right, and 0. So the axis of symmetry, it goes through the middle of the parabola, and it's x equals 3. The domain, as usual, is negative infinity to positive infinity. Now, since the function has a minimum value of 0, it means that the range of the function is from 0 with a square bracket to positive infinity, and the function has a minimum value of 0. Y equals 0. Let's take a look at the next function. So last but not necessarily least, we have quite a few combinations. So we have a reflection, a stretch, a horizontal translation, and a vertical translation. So we have to reflect the function because we have negative 3, so a is negative. The function is stretched by a factor of 3, so every y value is amplified by a factor of 3. We are shifting the parabola 1 unit up and 4 units to the left. So in terms of the vertex, we should find the vertex at negative 4 and 1, since h is negative 4 and the k value is 1. So moving the function 4 units to the left and 1 unit up, we are going to move to the left of the function. So 4 units left and 1 unit up. We're at negative 4 and positive 1. However, since the function is reflected, we have to go down 3 units for every increase or decrease in the x value. So we're drawing the new function in red right now, and then we're going to try and fill in all the information required about this function. So let's see what the axis of symmetry actually looks like. We always talk about this axis of symmetry splitting the parabola in two. Let's actually draw it as a line. It's going right through the vertex, splitting our parabola in two. And it goes at x equals negative 4 if you're looking at it. The domain, as usual, it's all real numbers, so from negative infinity to positive infinity. Looking at the range, we have to take into account that the function has a maximum value of 1. So the range is from negative infinity, and I apologize for the 0, the pencil got the better of me here. It's from negative infinity to 1, and the maximum value of y is 1.